Okay, so Unit 4.5 is looking at formulas. So the big part of it is looking at formulas and using them to answer questions and situations, and then also to be able to rearrange formulas and isolate for different variables depending on what we need for the question. So here we have, just grabbing my calculator, so I'm going to need that. Okay, so here we have a definition of what a formula is. So it's a mathematical equation that relates two or more variables and generally represents real-world situations. So for example, here we have a formula given where they would use it in a hospital to calculate the dose of medicine to give a child. So you'll see various letters used for different amounts. So C is going to be the child dose, right? So when you go into a hospital, you might have measurements for an adult dose, but you have a child that you have to treat. So you want to convert that adult dosage to how much you would give a child. So C is going to represent the child dose. And then A is representing the adult dose, and G is representing the child's age in years. So be careful when you're doing these questions to always read the question through completely and to understand what the different letters are representing. So you just don't want to go throw some numbers in. You want to read through everything. What are the numbers representing? What are the units that are being used in this formula? So the question says, determine the dose of medicine to give a 3-year-old if the adult dose would be 600 milligrams. So I have my formula here. And I'm just going to write down the information that I know. So the adult dose, A, is 600. The child's age is G, and that's 3 years old. And that's all I need to determine the child dose. So I'm just going to plug those numbers into the formula. So A is 600, G is 3, and at the bottom we also have G again, and 12. And then whenever you're solving these formulas and trying to find a value, remember that you always want to follow BEDMAS, right? You want to do any brackets first, then any exponents if they appear, and then you're going to multiply and then add and subtract in that order. So the first thing I might want to do to simplify this is to multiply 600 times 300, that is in the numerator. And at the same time, I can add the 3 and the 12 because they appear together in the denominator. And then I would just divide 1800 by 15. So 120 milligrams. And then the last thing I want to do is just make sure that that answer seems reasonable. So thinking about what I'm looking for in this question, I want to obviously reduce the dose for a child. So a 600 milligram dose would be reduced to 120 milligram dose for a child. So that seems like a reasonable answer. That seems like, you know, an amount that I would give a child as compared to an adult. And make sure that you always include units if they are given, right? They're not always given, but if they are given, make sure that you include the units. Okay, so here's another one. Sometimes I have to sort of problem solve here. So it says, using a formula to solve a problem, a landscaper wants to estimate the cost of fertilizing a rectangular lawn with length 150 and width 200. So there's some information that I have. I'm going to draw a diagram. Does it matter that the width is longer than the length? No, it doesn't. There's no rule that says the length is longer than the width. If it's a rectangle, you just assign one to be the length and one the width. Okay, so I have I want to fertilize this lawn with these dimensions. I know that 1 bag of fertilizer costs $19.98. That's tax included, so I don't have to worry about tax. And 1 bag covers 900 meters squared of lawn. So I want to figure out how much it costs me to cover this lawn. So I would say that the first thing I need to do is figure out, well, what area do I need to cover? So I know area is length times width. So I will sub in 150 times 200 and see what area that is that needs to be fertilized. And that is 30,000. And it would be meters squared because I'm multiplying meters times meters, okay? So then I might say, well, then how many bags do I need to cover that area? So how many bags do we need to buy? Keep in mind that you can't buy part of a bag, right? You can only buy whole bags or full bags. Cannot buy part of a bag, right? So it has to be a whole number. So I'm going to take the area. So the number of bags I will need will be the area that I have to cover divided by the area that 1 bag covers, which is 900 meters squared. So I'm going to do 30,000 divided by 900. And that's 33.3 bags, right? My units cancel. Or 34, right? Because I can't buy a third of a bag, so I need 34 to make sure I have enough. And then once I know how many bags I need, I'm going to multiply the number of bags times the price, which is $19.98. And let's see what we get. And we get $679.32. Okay, so some of these questions will be multi-step. You sort of have to problem solve through them and make sure that you are kind of thinking about, you know, what do I need to determine to get to this final solution, right? So with this one, if I want to know how many bags I want to buy, I think, well, how much area do I need to cover? Which in turn asks, well, how many bags do I need? And then I can figure out the cost. Okay. This is the third example. So now we want to use a bucket to fill up this rectangular planter. Okay, so I want to know how many times do I have to fill this bucket with soil to fill up this planter. So if I'm thinking about this, I think, well, how many buckets do I need? So we're talking about volume here, right? How much space this takes up rather than area. So when I'm filling something, I'm talking about volume. So I want to look at the volume of the planter, and I want to divide by the volume of the bucket. Right? And that will tell me how many times I have to put that amount from the bucket into the planter. So I need the volume of the planter, and I need the volume of the bucket. So those are two items that I need. While the planter is a rectangular shape, so it will be the length times the width times the height. One thing I do notice is that the length is given in meters, whereas the widths are given in centimeters. So I can either change everything to meters or everything to centimeters. I also noticed that the bucket is in centimeters, so I might as well change the meter to centimeters, which will be 100 centimeters in a meter. So that will be 100 centimeters long. Okay, so I need to have all units the same. And then I'm going to multiply length times width times height. So get out the calculator. And we get 80,000 centimeters cubed, right? Power 3, because we're multiplying centimeter by centimeter by centimeter. Okay, the bucket is a cylinder, right? So when you are having these formulas, I will give you the formula that you will need for that question, or there will be a formula sheet. So volume of a cylinder is area of the base, which is a circle. So pi r squared times the height of the bucket. So that's how we find the volume of a cylinder. So we're going to use pi. The radius is 18, and the height is 18. So we'll type that in the calculator. It doesn't matter whether you use pi or 3.14. It's not really much difference. I just use 3.14, and we get that volume. Okay, so once we have both volumes, we can then do the volume of the planter divided by the volume of the bucket to see how many we need to fill it. And of course, we'll round to the nearest whole bucket, although we probably could fill up part of a bucket. Let's see what we get. So we get 4.37 buckets. We need 4 and a bit, or approximately 4.5. Okay, but with the bucket, we could obviously fill up part of a bucket. So we could leave it as 4.37 if we need to. Okay, so the first part of the guide is looking at formulas and just using them to solve questions. Generally, the formula will be given to you, or you will have a formula sheet. So there are some practice questions in there. For example, question 7 gives a formula that tells you how many games must be scheduled. So when you're organizing a tournament, right, every team plays another team once. So we have a general formula that will determine, well, how many games we need to schedule in total for so many teams. Okay, so G is number of games we need in total, and N will be the number of teams in the tournament. So we have G equals N times N minus 1 over 2. So A says, well, how many games must be scheduled for 6 teams? So all we have to do is just sub in 6 teams where we see the N, and that will give us the answer. So 6 minus 1 is 5, so do brackets first. So 5 times 6 is 30, divided by 2, we would have a total of 15 games that need to be scheduled. Okay. The second part says, will the number of games double if the number of teams double? Justify your answer. So when we want to justify our answer, we want to have some sort of proof, right? So some sort of mathematical proof that will support our answer. So we know that 6 games or 6 teams equals 15 games. So let's double up the number of teams. So let's do 12 teams and see if that gives us 30 games, right? And then that will prove whether we're right or wrong. So I'm going to put in 12. And grab my calculator. So we've got 12 times 11, and then divided by 2 is 66 games. So no. So no, the doubling the teams does not double the games. And there's my proof. Because when I doubled teams, I would expect 30 games if it was correct, but I got 66. The other thing I could do is 3 teams, right? And see if I had 7.5 games, which obviously can't have half a game, but it would support the argument going the other way as well. Okay? All right. This one, they give you a formula for selling t-shirts. So cost is given as 300 plus 7n. So what does that mean? So n is number of t-shirts. So 7n means $7 for each t-shirt to make. And then $300 is a fixed cost. Right, so that might mean rental of equipment or rental of a building where I'm making the shirts, or maybe, you know, things like salaries and things like that. So something that's the same every, I don't know if it's month, okay? And then 7 is the variable cost, where things like materials for the shirt, so $7 for each t-shirt I make. So it says determine the cost of making 200 t-shirts. So I just used the formula. 7 times 200. And then add it to 300 fixed cost, gives me $1,700. Okay, so that's fairly simple. And then B says profit is the difference between revenue and cost. So profit is the money you earn when you take your revenue, right, what you get from selling, and subtract the cost it took to make the item. Okay, and the difference is the profit. So determine the profit from making and selling 1,000 t-shirts. Well, they give me a revenue equation, and they give me a cost equation. So the revenue equation is N 15 minus N over 200. And then cost is 300 plus 7N. Okay, so I want 1,000 t-shirts. So we've got N is 1,000. 15 minus 1,000 over 200. So that's my profit. And then I'll put the 1,000 in here to get my cost. So the first bracket, order of operations. The first thing I would do is brackets. I want to simplify that bracket. So the first thing inside the bracket, I would divide the 1,000 by 200. So I want to do division before I do subtraction, right? Bed mass. So within this bracket, I want to divide 10 or 1,000 divided by 200, which is 5. So I want to do that first. Okay. In this bracket, I want to multiply the 7 by the 1,000 first, so 7,000. Okay, then I want to finish my bracket by subtracting 15 minus 5, which is 10. And then in this bracket, I can add, oops, not 37. I can add 7,000 plus 300 is 7,300. And then finally, in the first bracket, I'm going to multiply 1,000 by 10, which is 10,000. And then we can subtract those two numbers. So there's our profit. So again, the formulas are given. You just have to follow order of operations. Right? So in this bracket, I want to do the division first. Once I've done the division, I can do the subtraction to finish the bracket, and then I can do the multiplication. Okay? So you just have to follow those order of operations in solving. Okay, I have one more question using formulas. So you can see that they generally give you the formula. So you have a tank, which is sort of a cylinder with half circles or half spheres on the end. And it wants you to determine the surface area using the formula. So it gives you this formula. So you don't have to figure it out. So surface area is 4 pi r squared, where r is the radius, plus 2 pi r L, where L is the length of the cylinder. So here's the length of the cylinder given as 7.2 meters. Here's the radius given as 1.25 meters. So all I have to do is substitute those numbers into the formula. Don't have to figure anything out. So the radius is 1.25. And the length is 7.2 meters. And they're both in meters, so that's great. I don't have to change any units. And then I just have to follow bedmass. So the first thing I have to do is exponents in this one. So I'm going to multiply 1.25 by 1.25. So 1.5625. In this part, I could just multiply all numbers together because I just have multiplication, right? There's no other operation, so I can just go ahead and multiply all those numbers together. So that's 56.52. And then in this first term, I can now multiply those three numbers together. So that's 19.625. And then when you are looking at this later, you can try this out for yourself and make sure that you get these same values so that you know how to type it into your calculator. So the total surface area is in meters squared. Okay, so 76.145 meters squared. B says determine the cost to cover the tank with 2 coats of paint. 1 can of paint costs $34.99 and covers an area of 29 meters squared. So let's think about this. We want 2 coats of paint. So we need to double the surface area. Okay, so 2 times the surface area would be 2 times 76.145. So we need to cover 152.29 meters squared. Okay. Then we know that 1 can covers an area of 29 meters, so we can determine the number of cans of paint that we need. So 152.29 needs to be covered. Each can covers 29 meters squared. And we will just divide those two numbers. And we need 5 1/4 cans. Well, we can't have part of a can, so 6 cans, right? Because we don't want to get 5 and then not have enough to finish the job. And then once we have the number of cans we need, we can then multiply by the price per can, which is $34.99. So we'll just multiply 6 by $34.99, and we get $209.94. Okay, so another question where they're going to ask you to calculate cost, right, which is a kind of a couple of steps problem because you have to figure out how many cans or bags you need before you can determine the cost. Okay, so there are quite a few practice questions in that part of the guide. So